Hello and welcome to the DIY Light Lab. I'm Brenton, and today I'm going to walk you through the process of installing permanent LED trim lights, start to finish. Paying for a professional install of permanent trim lights is a financial kick to the groin for most of us, usually starting around $30 per foot. And the further you dive down the rabbit hole of do-it-yourself LED lighting, the more confusing it can get. For my very first trim light project, I ended up doing about 30 hours of research, 20 hours of installation, and another 10 hours of troubleshooting. It was way too much, and depending on how you value your time, arguably more expensive than just paying for someone to do it. But I'm going to filter through all of that information, and I'm going to give you 30 minutes of value-packed instruction. By the end, you'll know what you need to do to design your lighting system, which components you need to build your system, and the best ways to install the system on your home. Also, at the end of this webinar, I'll offer you a special discount unique to you viewers to sign up for our full course, LED Lights 101. It's a comprehensive guide to installing trim lights, and in the course, I'm going to set you up so that you can reduce that 30 hours of research down to a short course, a multi-day installation down to one, and save you a lot of money. A modest house will cost you $3,000 to $6,000 to have permanent trim lighting installed by someone else. You're literally gonna save thousands of dollars by doing it yourself. If you follow the recommendations in the course and keep things lean, you can do it for closer to $600. And then, next time December rolls around, you can turn on your lights with your phone while you stand at the window in your slippers, sipping horchata, watching the snow fall. And you can bask in the thought that you'll never have to hang lights ever again. So, let's dive in. Step one, you're gonna need to dust off your 8th grade science lessons. Building your own custom LED lighting system for your house is going to require some basic knowledge of electricity. Nothing you probably didn't cover in science class at some point, but if you've forgotten the difference between volts and amps, you're gonna wanna brush up. Let's do a quick and dirty overview just to cover our bases. We'll start with a basic electrical system. Basic electrical systems have a few things in common, whether you're talking about the grid or an itty-bitty custom LED lighting system. The first is a power source. This is where the actual electrical power is being generated. Then we've got electrical wires. These obviously transmit the electrical power from place to place. Then a distribution or a substation or some sort of controller. This is where larger amounts of electricity are transformed into smaller amounts that can then be distributed properly. And finally, we've got our loads. These are the things that actually consume the electricity, like an appliance or a light. So how does this apply to a basic LED lighting system? Your LED system will start with a power source. This converts the higher AC voltage coming from your wall outlet into a lower DC voltage that's compatible with your LEDs. Your newly converted electricity then travels along electrical wires to a controller that acts as your distribution hub. The controller then distributes electricity to specific loads, which are your lights. Additionally, your controller will either include software that can control your lights, like color, brightness, patterns, effects, or it will be able to communicate with software on the internet that can control your lights. All right, step two, we're gonna make a plan. So there are about 1 million ways to go about creating your custom LED lighting system, and it's going to be a lot easier to figure out which way you're going to do it if you make a few decisions up front. When will you be using them? What do you want them to look like? Maybe you're just tired of icy ladders and those numb fingers from putting up Christmas lights in December, or maybe you're just really festive. Whatever it is, jot it down because it will influence what types of lights you need to buy and how you should mount them to your house. So for example, if all you care about is Christmas, you probably want your lights to look like traditional Christmas lights. This means you're probably gonna want a more simple controller, and you're gonna want lights that face outward and have more spacing between bulbs. But if you're an obsessive Halloween house hunter, then you might want a controller that can sync with music or sound effects, and you want the lights to spill onto the walls of your house. Or maybe you don't care at all as long as people can't see the bulbs during the day. Then you've got to think about which combination of lights and mounting options are just less visible. So, designing your system. Once you've got this vision of how you want to use your lights, then we can start actually designing the layout of the system. You can start by identifying all the different lengths on your roof lines where you want to install lights. Every roof's gonna be different, but there are a few principles that you should be able to apply to your unique roof. First, stick to the eaves, or the part of your roof that overhangs past the walls of your house. Most mounting options are made to attach to the soffit, which is the underbelly of the eave. So avoid places where you might have to mount directly to your house or shingles or other random places. Next, consider what it will look like from the street. I recommend doing all your eaves that face the street, and that includes all the various peaks and dormers that you might have. Skipping any of these sections is gonna make your lighting feel incomplete or unprofessional. That said, you gotta think about safety. This is a DIY project. Which parts of your roof are actually realistic for you to be able to safely access and install lights? You're gonna be on a ladder with a drill gun, holding 4 to 12 feet of channel and trying to mount it straight. So think safety. All right, once you know where you want your lights, it's time to decide where you'll put your power supply and your controller. The main requirement for this location is a power outlet. After that, it's just kind of nice to haves, but here are a few recommendations. First, make it central to your lights. It's likely that you'll need to split your lights into multiple circuits or zones in order to avoid what's called voltage drop. Basically, your LED system is low voltage. It can only transport electrical power so far before it peters out. Next, you gotta protect it from the elements. Your control center will include your power supply, your controller, and sometimes other electronic components. Like most electronics, they don't work so well when they get wet. Also, you wanna consider how you'll run wires. Because my control center is in my attic, I was able to drop wires directly from the attic through the soffit to my light. The attic comes at a cost though, which brings me to my last recommendation, and that is think about ease of access. All right, time to get some accurate measurements. So knowing exactly which lengths you're working with are going to help you make some critical calculations. For one, it's going to tell you how many strings or strips of lights that you need to buy and how many feet of wire it's going to take to wire the whole thing. It's also gonna help you calculate how much power each zone will consume and which controller that you will need to manage it. So I'd recommend getting outside on your ladder, measuring exactly, and then taking note of some specific lengths. Lastly, I would suggest diagramming it all out. This will be the mechanism by which you can reference and edit your system on paper before you go buy all the components and lay it out in the garage. It will be extremely handy as you make calculations to determine which power supply you want, which controller you need, as well as whether or not you'll need to do power injection. But before we move on to step 3, I want to quickly acknowledge that we're moving through this really quickly and that you may have questions along the way. It's okay at this point for your plan to be a little loose. As you start picking out your components, that plan's gonna tighten up. Also, if the questions are really piling up, that's why we created a full course for this. It's designed to guide any level of DIYer to a great looking light setup. Not to say it won't require work on your end, but it will walk you through every little detail you need to build your system in the least amount of time possible. Step 3, choose your components. All right, with your plan in place, it's time to make some decisions and get all your components gathered. So we'll start with lights. This is a good place to start. And the first thing I'd suggest deciding between is strips or strings. Strips typically have a higher pixel density, which makes your lighting effects or your animations and patterns feel more modern or futuristic. They're also really thin and compact, and it's easier to make them effectively invisible during the day, especially if you're using diffusers, which I do recommend. However, strips can be more fragile than strings, and they can be a bit more difficult to repair while you're on a ladder. Strings typically have a lower pixel density, meaning there's more space between pixels, and are your best choice if you want a more traditional holiday light aesthetic. You'll be able to see each bulb individually. Strings tend to be more durable, and repairing a bad pixel is a bit easier than repairing strips. Because the pixel is housed with a bulb that protrudes from the channel that you'll mount to your eaves, they tend to be more visible than strips during the day. That said, they're still pretty difficult to spot if you do them right. Next, you've got to decide between 5-volt and 12-volt lights. 5-volt systems are typically going to be a little easier on your power bill. They tend to be safer, and you may find that 5-volt light systems respond better to your light controls. They typically require lower signal voltage. However, you're more likely to run into brightness and color issues with a 5-volt system because of voltage drop. Your cable runs can't be as long, and you can't put as many lights on a circuit without injecting more power along the way. In a nutshell, if you've got shorter runs or plan to run your lights constantly, you may want to go with 5 volts. If you hate the idea of injecting more power in between strings of lights and don't care if your power bill takes a hit, then 12 volt might be right for you. All right, so let's talk controllers. Next, you gotta pick out your controller. Hands down, our recommended controller is the Dig Quad, developed by Quinn LED. This is a controller designed specifically for LED pixel lighting. It's made for people like you who want to build their own LED lighting system, but maybe aren't electrical engineers or lifelong lighting hobbyists. This controller supports both 5-volt and 12-volt systems. It plays really nicely into the ecosystem as a whole and is compatible with a wide range of LED lights. It comes ready to use with WLED, which is the software that we recommend for controlling your lights. And the combination of Dig Quad and WLED will give you essentially everything you need to control your lights, custom colors, patterns, effects. You can even sync multiple Dig Quads together to control as a single unit. Also, the Dig Quad comes pre-assembled, so when you get it, there's no soldering or piecing together parts on a breadboard or anything like that. You pull it out of the package, there's a few steps, plug it into your lights, hook up your power supply, sync it with the LED software, and you're off to the races. All right, lights, controller, action. Just kidding, kind of. We've covered lights, we've covered controllers. However, we still can't even get a string or a strip to light up because they're not getting any power. So to remedy this, you've got to select a power supply that will convert 110 AC volts from your wall outlet to 5 volts or 12 volts DC that will feed your board, which in turn will then distribute power to your lights. So feel free to shop around on this one, but there are 2 brands that I recommend that are widely used and highly reviewed for reliability. Meanwell makes both 5 volt and 12 volt options for power supplies that are available on Amazon, and Alatov makes slightly cheaper options than Meanwell. Be sure to snag a power cord because you might have noticed as you're shopping that these power supplies don't come with a power cord. This is simply the cord that plugs into your wall outlet on one end and connects to your power supply on the other end. So let's talk wiring and other accessories. There are a few other odds and ends that you'll need to pick up as well. So for starters, you're gonna need to snag some wire to run the newly converted DC power from your power supply to your board. I suggest getting some red wire for the positive terminals and some black wire for the negative terminals. Additionally, it's very important to select the proper gauge of wire for your system. There are online calculators or ampacity charts that you can use to calculate what you need, but be sure to consult with a licensed electrician if you have any doubt about which wire gauges you should use. So worth noting is that the Dig Quad controller has 2 positive and 2 negative terminals, as does the power supply. Spreading the load across 2 sets of wires like this does give you some wiggle room in the wire gauge. Other controllers may only have 1 set of positive and negative terminals though, and you may need to use a larger gauge to compensate. Additionally, you'll need some LED wire on hand to run from your controller to your strings or strips, as well as any mid-string runs where you don't want lights on your trim. A few more handy odds and ends might include things like wire ferrules that are gonna make connecting wires to terminals a bit easier. There's also spade connectors. Spade connectors make for a clean connection between your power supply and controller. For strings, waterproof solder tubes will be important for splicing your strings together without a soldering tool. Pigtails and other connectors are not always waterproof. Then for strips, waterproof strip connectors can be handy for splicing strips together without soldering, though if you're using strips, you may want to just invest in a solder tool and learn how to solder. Waterproof wire nuts, these are handy to cap off any bare wires, and doesn't hurt to have some electrical tape around. Just comes in handy. All right, so once you've got your lights, controller, power supply, and all the wiring squared away, it's time to start thinking about how you're going to actually mount the lights to your trim. The answer is channel. In short, you'll be mounting channel to your eaves and housing your lights inside of the channel. There are many types of channel out there, and we're gonna make a few recommendations. Let's start with channel for string lights. So your least expensive mounting option for string lights is going to be getting something similar to this 5/8 inch J channel from the Home Depot. And you're gonna have to drill your own holes for the lights to mount in. This vinyl J channel costs about 63 cents per foot, so cash out of pocket, it's significantly less than the alternative of buying pre-drilled metal track. The downside, you gotta drill your own holes, and that can take a minute. This is what I used on my own home, and I feel like it was worth the savings. If you go this route, though, you'll want to use a jig to keep your holes perfectly spaced and aligned so it looks professional, and using a jig is gonna save you hours worth of measuring and marking. Permatrack is pre-drilled metal channel. This is a really great option for pre-drilled. This will save you a couple hours drilling holes. It's a bit sturdier than the J channel, obviously, and is handy to mount. It also provides either option of pointing your lights downward or outward, whereas the J channel is really best suited for pointing lights outward. The downside, it's significantly more expensive, ranging from $350 to $4 per foot. For strips, you've got a lot of options. Products and pricing may change fairly frequently, so shop around. However, in general, we recommend sturdy aluminum channel that has tinted or curved diffusion that keeps a good bit of distance between the LEDs and the diffusion. This is going to help reduce hot spots, so being able to see individual lights, and it's gonna make things more consistent across the strip. If you plan to mount your power supply and controller on the exterior of your house, or if you're mounting things inside and you just like to keep things tidy, you can get a waterproof junction box to house your power supply and controller. This will protect them from the elements, and all of us cable management nerds get to geek out on how we want to configure the box. Step 4, installation. All right, if you're confident enough to take on a DIY project, I'm going to assume that you know your way around a drill gun and a ladder and some other basic DIY stuff. So that means we can move pretty quickly through this step. First step, I'm going to suggest that you prep and mount your channel. This mostly applies to those of you who choose to use vinyl J channel from the Home Depot. You've got a lot of drilling to do and you're gonna wanna get after it. For starters, you're going to want to determine your spacing and make your own jig. It's also important to note the exact size of the light. A lot of string light options are 12 millimeters in diameter, which is temptingly close to a 1/2 inch. However, 12 millimeters is 0.47 inches, and that extra 0.03 inches will make your lights sit in the holes a bit sloppily. If you're going the Permatrack route or a similar pre-drilled channel, it comes ready to mount. So just be sure to purchase lights with the correct distance between your LEDs. So the Permatrack holes are spaced 3 inches apart, and a lot of strings that you'll find on Amazon and AliExpress do have 3-inch spacing. Though I found that those strings were a little easier to install in my J channel when I spaced them at 2.5 inches. So you might consider looking for strings with 4 inches spacing just to give yourself some wiggle room. As far as mounting, so for the J channel, I suggest mounting the channel before you put the lights into the channel and placing screws often enough to keep the J channel flush with your eave. The Permatrack, this is designed so that you can install the lights before mounting. So you put them in the channel before mounting, and it comes with brackets that you mount first, and then you simply click the track with its lights in it onto the mounting brackets. However, before actually installing any lights on the house, I recommend doing a garage build. This is where you will assemble everything. Plug it in, test for quality assurance, make sure it all works before you have to troubleshoot and fix stuff while you're up on a ladder. You're looking for lights that don't work or signs of voltage drop and other anomalies. The whole reason for doing this before install is to get all your troubleshooting out of the way while you're in the garage and everything is more accessible. If you've planned well, made accurate calculations, and kept all your splicing really tidy, you shouldn't have any issues. If that's the case, well done, and you're off to the races. We can get those lights hung up in the channel, bust out those awesome cable management skills, and get your control box set up and mounted. If you are having issues, well then, it's time for some troubleshooting, which brings us to step 5, troubleshooting. Let's start with one of the most common issues that I've seen, flickering, inconsistent colors, colors getting warmer at the ends. This could be due to a bad connection, preventing the proper amount of power getting to your lights. You might start by checking connections, making sure that they're tight and clamped down well. Make sure all that voltage is there to push the current through. Your runs might be too long. If you haven't calculated properly, you might have too many lights and you might need to insert more power down the line somewhere. Another issue is that you could potentially be having data interference. Sometimes if you run data alongside the positive and negative wires, which a lot of LED wire runs them together, you can run into data interference. This can be solved with a data booster or running the data line separately. If you got lights that won't turn on at all, you might have a backward string or a bad string of lights, or you might have a bad splice somewhere. You can also check for blown fuses. Sometimes you can blow a fuse if exposed wires touch somewhere down the line, or if you've accidentally connected terminals with your screwdriver on accident. Another issue that you might run into is lights turning off or on randomly. If this is happening, there's a good chance that it has to do with the software that you're using to run the lights. So if it's WLED, try rebooting. You can also redo your configurations within WLED. If you've got it on a timer or something like that, you can tweak the times or delete and re-enter the data. Sometimes this will reset things. If you got half a string that's not working, you might have a bad LED. I recommend cutting it and the previous one out, just in case it's the previous one that's causing the issue. So I'm keeping this troubleshooting section pretty light. If you've gone through, you've taken note, you've done really good calculations, you shouldn't be having issues. If the issues are piling up, you've got things you can't figure out, we do go a lot deeper into troubleshooting in the full LED course. You can find more answers there. Otherwise, there you have it. 5 steps to designing, building, and installing your custom LED trim lighting. So now comes your discounted offer for DIY Light Lab's paid course, LED Lights 101. It's a comprehensive guide to installing trim lights. In the course, we're gonna do a lot of stuff. We're gonna dive deeper. We're gonna get a lot more nuanced. We're gonna do things like give you a project plan template that you can use to design your system. You can use it to estimate your costs before you spend any money. You can even use it to calculate your power consumption across the system, things like that. We go over more on basic electric systems, reviewing different lights and controllers. We share lots of recommendations. We provide access to comprehensive shopping lists, and we walk you through power injection and just a lot more. So like I mentioned earlier, whether you're a confident DIYer who just needs a few more pointers on setting up your system, or if you fall more on the kind of fake it till you make it end of the spectrum, this course is gonna make sure that by the end, you have a great looking custom LED light setup. I wish that I had an option like this available to me when I first dove in. There really is a great community around LED lighting out there. There's tons of content to pull from, but a lot of it assumes that you already know quite a bit about the ecosystem. I would have gladly invested a chunk of the money that I saved not paying someone else to put in a system for me. I would have loved to invest some of that into a resource that saved me 30 hours of research and a ton of time and money with trial and error. Since we're in pre-launch phase, we're offering a price that we'll never offer again to sign up for the course right now, and that's $29. When we launch in the coming weeks, the sticker price will be somewhere north of $120. However, to say thank you for signing up before the course is even live, we will give you access for the same amount it costs to take your friend to lunch to pick their brain on something. Not a bad investment if you want to save upwards of 50 hours of research, sourcing parts, troubleshooting, not to mention the thousands that you'll save by doing this project yourself. We're also capping this price at the first 100 people. I can't guarantee how long before we'll hit that number with our pre-launch, so the best way to lock in $29 is to sign up right now. Once we hit 100 signups, we'll update this offer and you won't have access to it again. And while you mull that over for a second, let's do some Q&A. All right, let's dive into the Q&A. I've got some commonly asked questions pulled up here that we'll walk through. First up, what if I have a detached garage? Well, depends on how you want to do cable management. So doing a little brainstorming with you, you could run cable like a power line from building to building, or if you want to keep things tidy, you can go into the ground, much like you would with a sprinkler system. That's gonna lead you to digging a trench, running conduit, and fishing your wire through the conduit over to the detached garage. If the garage has power, you could set up a separate unit in the garage or for the garage, mount a different controller there in the garage, and have your controller synced on WLED. Next question, are the bulbs easy to replace, and can you buy individual bulbs? It's gonna depend on your lights that you choose. Typically, from what I've seen, probably a good idea to have some extra lights kicking around. So have an extra string, because when a bulb does go bad, you're gonna wanna snip that bulb and the previous bulb out, and then take good bulbs from your extras and splice those in. I have gutters, but not soffits. How can you install 2 gutters? So there are some professional companies out there that will drill holes right in your gutter. I don't recommend it. Gutters are expensive. They're a lot more expensive than buying J-channel. I don't recommend drilling holes in your gutters. If you want to take that on, just make sure it's high enough that the water isn't leaking out. You could also consider LEDs that probably have some less invasive ways of attaching the channel to the gutter so that you're not having to drill holes into your gutter. But do not drill channel onto your gutter. You'll end up with leaky rain gutters, and you'll have to replace those, which will be really expensive. Okay, next question. How close does my controller need to be to my router in order to work? Depends on the controller that you get, and depends on where the house situation. If you've got it barricaded in a concrete room, obviously it's not gonna get as good as distance. But think of it like any other electronic device that's attached to your Wi-Fi. You've got a pretty average range there. You know, maybe the washer's sitting on the other side of the house from your office where the router is. Like, it's gonna be pretty similar to all those other electronic devices that you've got attached to your Wi-Fi. What types of screws do you use? Personally, I like the self-tapping metal screws. They go into the soffit nice and easily. Definitely my preference there. What size drill bit do you use on the J channel? Depends on the light that you bought, but for a lot of the standard bullet lights that you'll find on Amazon, they're 12 millimeters in diameter. That's really close to a 1/2 inch, but make sure that you use an actual 12 millimeter drill bit for those. Be precise. It's going to help the light stay snug where it should be, so you don't have your lights going at wonky angles. How do you bridge the gap between levels? I'm assuming this is talking about bridging gaps between strings of lights that you want to run together. You're gonna bridge those gaps with LED wire. So you'll cut the lights where you want them to end, you'll splice in LED wire, you'll run it to where you want the next string to begin and hook it up there. So you'll manage your gaps that way. If Dig Quad is excessive for my setup, should I still get it, or can I use the Dig Uno? You can use the Dig Uno. It's just got fewer ports and less capacity to power lights. However, for the price difference, I definitely recommend the Dig Quad. It's gonna set you up for expanding that if you want. Where and how often do power injection points need to be? This totally depends on the lights that you've chosen, what the density is, whether you're using 12 volt or 5 volt, the strength of your power source. Like, there's a lot that goes into this. Definitely recommend doing your calculations ahead of time and making sure that you know how much your system can handle before it's actually installed on your roof. As far as location of where that power injection happens, every string of lights is gonna have some power injection cables at the beginning and the end of the string. You're gonna end up running power wire for those power injection points, and that's where you'll insert it. Are there issues with having the controller in the attic with hot and cold temperatures? I personally have my controller in the attic. I haven't had any issues with it. However, check out the specs on the controller. Make sure that it's rated for certain temperatures. If you live in Arizona, if you have a controller in the attic, you might want to check and make sure that it's not going to get too hot for your controller. Okay, how far apart should the mounting brackets be? It depends on your channel. But for me in the J channel, I ended up going about every 4 feet. But the primary principle to keep in mind is you just want that channel snug up against your soffit. You don't want it sagging anywhere. It's going to leave gaps and make it look sloppy. That's it for the Q&A. Thanks for watching our webinar. If you've made it this far, congratulations. And don't miss out on the $29. We don't know how fast that first 100 is gonna fill up, so make sure you snag that right now. Thanks, see you around.